Military radar systems. Eyes beyond the horizon. From massive fixed installations scanning for intercontinental ballistic missiles to compact systems aboard fighter jets, military radar systems form an intricate web of electronic vigilance across land, sea, air, and space. These electronic sentinels maintain constant watch, their invisible beams probing the darkness for threats known and unknown. Early warning radar facility. This early warning system can detect threats over 400 kilometers away. It's our first line of defense. The massive phased array allows us to track hundreds of objects simultaneously, from aircraft to ballistic missiles. When something enters our surveillance envelope, we know within seconds. Military analog. The trade-off is clear. Enormous power requirements and fixed positions make them vulnerable, but nothing matches their sheer detection range. These installations cost billions to build and maintain. The AN/FPS 132 can track an object the size of a basketball at a distance where most radar systems see nothing but noise. During times of heightened tension, we operate 24/7 at the system. The system processes terabytes of data hourly, filtering out birds, weather, and civilian aircraft to identify potential threats. A single missed detection could have catastrophic consequences. Airfield with E3 Sentry AWACS plot. From 30,000 feet, we can see hundreds of kilometers in every direction. We're not just sensors. We're the eyes, ears, and brain of the entire air operation. Our radar dome contains equipment that would fill a small building on the ground. Radar operator, what makes airborne radar special is perspective. Ground-based systems can't see beyond the horizon. Up here, we push that horizon out dramatically. I can track low-flying cruise missiles that would be invisible to ground stations due to Earth's curvature. Maintenance chief. These flying radar platforms come at a cost. Massive operational expenses and limited time in the air. Each flight hour requires about 30 maintenance hours. The radar systems generate enormous heat and require specialized cooling systems. One faulty component can ground the entire aircraft. Tactical coordinator, we coordinate with satellites, ground stations, ships, and fighter aircraft to create a comprehensive picture. In combat operations, we've directed hundreds of aircraft simultaneously across thousands of square kilometers. Battlefield Command Center Commander Fire Control Radar gives us precision. We don't just see targets, we track them with enough accuracy to engage. The difference between surveillance radar and fire control is like the difference between spotting someone across a football field versus threading a needle. Radar engineer, the narrower the beam, the more precise the tracking. But that precision makes them vulnerable to anti-radiation missiles targeting their emissions. Modern systems pulse irregularly or frequency hop to avoid detection. It's an electronic chess game, each move countered by the enemy's next innovation. Weapon officer. With target tracking radar, we can determine altitude, speed, direction, and even identify specific aircraft types by their radar signature. The AN/SPG-62, used in naval systems, can guide a missile to hit a moving target the size of a compact car from over 100 kilometers away. Advanced Technology Demonstration ASO radar represents the cutting edge. Thousands of individual transmit-receive modules operating in concert. No moving parts, incredibly fast scanning, multiple simultaneous functions. The system can track an air target while simultaneously mapping the ground and jamming enemy communications. Military officer, the future is passive and cognitive systems. Radar that doesn't transmit but listens. Systems that adapt to countermeasures in real time. Quantum radar may eventually detect targets currently considered invisible. AI integration means systems that learn, predict, and counter enemy tactics autonomously. Electronic warfare expert. Modern electronic warfare is about control of the electromagnetic spectrum. Radar warning receivers detect enemy emissions. Jammers flood frequencies with noise. Decoys create false targets. Digital radio frequency memory systems record and replay radar signals to create phantom aircraft. It's no longer enough to have powerful radar. You must protect it from an increasingly sophisticated electronic battlefield. Defense contractor miniaturization continues to advance. Systems that once filled rooms now fit in drones smaller than a backpack. Distributed networks of small, inexpensive radars can provide coverage comparable to massive fixed installations, but with greatly improved survivability. Counter-battery systems. Artillery officer counter-battery radar has transformed modern artillery warfare. Within seconds of enemy shells being fired, we can determine the exact launch location and return fire before they can relocate. The AN/TPQ-53 can track multiple projectiles simultaneously, calculating their points of origin with extraordinary precision. Field technician. These systems must be highly mobile, set up in minutes, scan for enemy fire, then relocate before counter-battery fire arrives. The electronic signature of an active radar is like lighting a beacon for enemy targeting systems. Naval radar systems ship captain at sea. Radar is everything. With no landmarks or terrain features, our radar systems are our only way to detect surface vessels, aircraft, and even incoming missiles skimming just above the waves. Modern naval systems integrate dozens of radar arrays operating on different frequencies to create a seamless detection bubble around the fleet. Naval engineer, saltwater, rolling seas, and limited space create unique challenges for maritime radar. Systems must compensate for a ship's motion in heavy seas. Salt corrosion demands specialized components and constant maintenance. Power management becomes critical. High-powered radar emissions can interfere with other onboard systems. From the massive early warning networks to the compact fighter-borne systems, military radar continues to evolve in the eternal contest between detection and evasion. In this invisible electronic battlefield, advantage shifts constantly between seeing and remaining unseen. Each advance in radar technology triggers countermeasures, which in turn spur new detection methods. Stealth aircraft beget multi-aesthetic radar networks. Advanced jamming drives the development of frequency-agile systems. The electromagnetic spectrum has become as contested as land, sea, and air. Beneath the technical specifications and operational parameters lies a fundamental truth. Knowledge of the battlefield conveys decisive advantage. Those who see first strike first. Those who remain invisible survive. This principle has driven radar development since its inception and will continue to do so far into the future. The electronic sentinels stand watch, scanning the horizons for threats both seen and unseen in an endless vigil that never sleeps. In the electromagnetic darkness, they are civilization's first line of defense.